Let's see if we can get some rain going here momentarily. Early start to taste of the rainy season here in Tampa Bay. Tropical, semi-tropical disturbance in the Bahamas. It's trying to work its way down to the surface. Trough of low pressure. It's pushing across Florida and will be crossing us tomorrow into Friday. And that will really kick up our rain chances. There's an outflow boundary coming from the south that is slowly propagating northward towards Tampa Bay from thunderstorms that are right now, not thunderstorms, showers, squalls of showers that are right now south of Tampa Bay. And so I expect as these come in, these reach us to get very squally weather here. Typical squally characteristics, some wind gusts around 30 miles per hour, heavy rain, maybe some gusts of 40 to 50 miles per hour in the heavier cells. Yesterday, there was a wind gust of 54 miles an hour at MacDill Air Force Base. So if you get a really heavy cell, you could have some wind gusts of 40 to 60 miles per hour, depending on how strong they can get, especially if you get multiple outflow boundaries, which is basically the cold air that rushes out ahead of a thunderstorm or shower. If you get a bunch of boundaries that come together or rain shower cells that merge, and you have these breezy conditions on the default, that can really kick up the winds. So we could get some pretty gusty winds, maximum of 40 to 60 miles per hour in gusts as these cells come together. Not a major severe weather outbreak, but typically when we see squalls from these non-tropical or disturbances or troughs of low pressure that are trying to go tropical, they can spit out some squalls, some of which may contain cells that can be quite robust and put out wind gusts of 40 to 60 miles per hour maximum. These are not the sustained winds. It's not a tropical storm, a full-on tropical cyclone, but when these gusts do come through with these squalls, they will be interesting to watch. You'll get to see several this summer. Every summer we always have these lows that cross the state, these troughs of low pressure that cross the state and bring us these squally weather several times a year. So if you keep watching this channel through the summer, you're going to see some. You can go back and look at my older videos from last summer or the summer before, and you'll find some footage of squalls. And if hurricanes are your thing, I have Hurricane Irma filmed on here, so on my channel. So go find Hurricane Irma and you'll be able to see the really strong gusty winds we had here during the course of that hurricane. Anyway, this is not going to be as strong as that, but it's going to be fascinating to study nevertheless. So these winds right now, these are the baseline winds. This is just from the pressure gradient. You have low pressure over the Bahamas, a trough, a high pressure ridge north of there out over the western Atlantic, and that is kicking up the winds, that pressure gradient. You get like wind being squeezed because around the high you get this clockwise flow, around the low the counterclockwise flow, and so you get a good east wind coming at us. Now, right as I speak at this second, as these raindrops, a few light raindrops, light sprinkles are starting to fall, and the winds might have a little bit more of a kick to them if this shower that is going to be moving over us in the next few seconds, if this shower is able to get strong enough and through evaporative cooling of the falling raindrops generate some colder air that comes rushing down to the surface, cooler air, it doesn't get cold here this time of year, that might kick up the winds a little bit. So yeah, you get those evaporative cooling sorts of events, and that can be something that helps enhance the strength of the winds during these sorts of events. So, and that's true in most places. You get a rain shower, that evaporative cooling will enhance some of that cooler air that's just above the surface in a storm. And then that cool air hits the surface, rushes out, and if you can get more evaporative cooling with that, you get stronger winds at the surface. The interesting thing is watching the outflow boundary come in from the south while all these cells rotate in front of it. So on camera, you can't see the outflow boundary yet. It's still just south of us. Perhaps these clouds right here, these clouds might be the leading edge of that outflow boundary that is south of us and propagating in this direction northwards. So that straight back there is west. This is north. I'm pointing north now. So you can see that outflow boundary right there. That's the outflow boundary. It's trying to propagate northward and intensify these cells that are coming through and producing this light rain. So the outflow boundary is moving from south to north, and the individual cells are moving from east to west, sort of like if we were at the top of the clock, these cells would be moving in a counterclockwise fashion over this part of the Florida Peninsula, which is what you would expect when you have a low to the southeast of you. You're going to get this counterclockwise flow. Low to the south of you, probably, yeah, southeast. You get this sort of easterly to northeasterly wind component around it because of counterclockwise flow. A lot of this terminology comes from studying in depth how the weather works, high and low pressure systems, and how they steer tropical storms or hurricanes, how they steer the precursors to tropical storms, which are tropical waves, or in our case, troughs of low pressure that at this time have not developed into a tropical cyclone, but have a chance of doing so. It'll cross Florida and then get kicked out into the Atlantic east of Florida. And as it accelerates northeast over the Gulf Stream, all those warm waters there, I think it'll have a good shot at becoming a short-lived tropical storm or subtropical storm, Andrea. Tropical storm meaning having a warm core. Subtropical storm, the core, I don't think the core is that. The core has to be warmer than the surroundings in that sort of situation. I'll have to look that up, but I think this could go tropical as it sticks out over the Atlantic long enough, just off the east coast of Florida. We are on the west coast, so we get the afternoon showers as they develop and move inland from the Atlantic onto the east coast of Florida, across the state, and it's 6:30 in the evening now. By 6:30, by this time, they are reaching us. They get here earlier usually, but today it's taking some extra time because that outflow boundary is taking time to propagate northwards and really ignite the cells. So yeah, 6:30 evening time here. We should be having these bands of rain move in.